Thank you, Natra, and I think a great initiative to organize this webinar on microbial management. Thank you very much for giving me a chance to give the opening presentation. Several of the participants, particularly from Asia-Pacific countries, will remember that I have touched upon this subject at a number of earlier occasions. I'm very pleased that this time we will be able to listen more to the field sector, so that maybe I can repeat a little bit on let's say, the scientific evidence and the need that was expressed already more than 10 years ago at FAO, that we should focus more on disease prevention. Disease treatment is, of course, important, but we should focus more on disease prevention. And it became also obvious with the new tools that became available that one of the priorities for the past decade was to focus on microbial management. And not the least because of all the problems that were showing up in the last decade, not the least with shrimp in particularly Asian countries. And you see that already in 2013, 2014, some of us at Ghent University were coming up with the hypothesis that maybe some of the problems might have been caused by improper microbial management. The same observation when you look at that big industry, the European sea bass and sea bream industry, a picture that is only a couple of years old. So the situation is still very similar to what you see here. Maybe an average survival in the bass and the bream hatcheries that has increased, maybe now up to the 30–35% area, but you see big fluctuations, big standard deviations. And most people are aware that it has to do with microbial community composition, but not being sure how to tackle it or what might be the real cause. Big change came when the new tools became available, and that suddenly it became clear that we have a huge diversity of bacteria in our aquatic environments, which we can simplify and split into the neutral beneficial bacteria. Honestly speaking, we had underestimated the beneficial role of a lot of these bacteria, but we're focusing most of the time on the pathogens, particularly the obligate pathogens, but we underestimated the role of the potentially harmful bacteria, the so-called opportunists, to which the Vibrio species group belongs. So in aquaculture, of course, we do not want to have any presence of pathogens and do disinfection, not realizing that just upon the disinfection, you get a new colonization. And this is where, without going into too much details here, the big difference between the so-called R strategists and the K strategists is something that the group from Norway, you will hear about in a moment, has focused a lot, been able to characterize these different groups, and where we see that the conditions in aquaculture, particularly upon disinfection and when we are stocking the ponds, favor these R strategists, and these are the ones that under certain conditions can express virulence. And what are these special conditions? Well, for example, quorum sensing. Quorum sensing, where these sophisticated bacteria communicate, interact, and when quorum, when a certain number is reached, only then they switch on virulence genes and reach a pathogenic status. One important characteristic, but this is where you see how science is developing. A number of old and new papers have learned about a new phenomenon, the so-called phenotype switching, where under influence, and I still put it under parentheses because all kinds of conditions, particular products or situations can also induce the Vibrio to switch on virulence, switch off virulence, a phenomenon which we call phenotype switching. And we are just recently, 2019, 2020, 2021, several new papers have been published. So this is the simplified animation on what is happening in our aquaculture systems. Upon disinfection, okay, we have eliminated the bacteria, but we get a quick recolonization. And this is where, under the conditions where we bring in the animals, we provide food, be it in the pond, be it in the hatchery tank, we see that our R strategists get a chance to develop, and provided time is given, we see that we will get a better distribution, a better harmony with the domination of the K strategists. And this is the situation where, in fact, we can assure the best conditions. Problem is that very, very often, and that's where we could learn from past empirical observations. Some of you will remember the times bioluminescence, Zouia-2 syndrome, bolitas, different vibriosis situations, which were caused by conditions where eventually the peak of the R strategists reached critical numbers. Many times people are asking, what is that critical number? Well, this is in fact where we still need more research to better understand what is happening. Changing the water, a very regular 30–40% change of the water on a daily basis is apparently, with disinfected water, is not a good idea, because then you are indeed washing out the bacteria, but you will give again a better chance to the R strategists than to the K strategists. Recirculation technology is the one where we know from past experience that this is giving good results. With the knowledge we have now, this is a system where the K strategists can dominate over the R strategists. And probably we will hear a bit more about from Kari, but I draw your attention to several good papers that have been published recently in the last couple of years on these phenomena. So a lot of the empirical observations of the past, which now we can link to microbial matured water, explain how we can favor these K strategists. The green water systems, the tilapia co-culture. We will hear a number of examples in the field presentations that are following. I'm just taking one where we have a nice illustration of that new phenomenon of phenotype switching. Biofloc systems, although we still know that in many situations this can be a favorable condition, but at times providing substrate for the bacteria, if you don't have the right composition, this could be a risky event. But it has been demonstrated, a number of papers, that animals produced in a biofloc system respond better in a challenge test. So apparently better prepared to an exposure to the Vibrio parahemolyticus. But in that paper, more research was suggested to try to understand the mechanisms. More recently, published just only a number of months ago, where the new technique where you could look into gene expression was applied. Now we can explain and see that the biofloc system in fact results in phenotype switching. So with this time, and it was first through the European Commission, but now also the FAO, that the so-called GAPs, which are considered like the Bible, that we need to adjust these, that we need to look into new recommendations. And that biosecurity, of course, is a crucial one, needs to be maximized, but that here we need to pay more attention to microbial conditions. And this is where you will hear in the next presentations on what kind of approaches are being taken up. I also draw your attention that live food is very critical. In many situations we have seen, be it algae or rotifers or artemia, that one has to pay attention also to the microbial conditions, because live food can easily be contaminated with the critical Vibrios. So we talk about specific pathogen-free conditions throughout the production cycle. This is also taken up by FAO. FAO that is giving more attention to these microbial management protocols, but indeed also agrees and concludes that we still need more knowledge. We have very good indications. I'm happy that we will hear several field presentations in the next presentations, but this is not the end. We still need to learn further about the specific behavior of these bacteria and how we can develop systems to control this KR strategy concept. Thank you very much.
Thank you, Patrick. So let me remind all of you again that Q&A would be at the end of the session. And if you have any questions, please use the chat box to address your questions, okay? All right, so